Theoretical recap. On Linux, a process is a running instance of a program, identified by a unique PID, process ID, and linked to its parent through a PPID. Each process has an owner, the user who launched it, a state, running, sleeping, zombie, stopped, and consumes resources such as CPU and memory. The correct mental model is a family tree, init/systemd, PID1, is the root, and every other process descends from it. Killing a parent can orphan or terminate its children. To inspect processes, you have two families of tools. Static snapshots come from PS, for example PSO or PSF, which lists every process at a given instant. Dynamic, live views come from top and uptop, which refresh continuously and let you sort by CPU or memory. Filtering is where the real skill lies. PSO, grep SSHD, PG brep uroot, or PSEO PID, user, %CPU, %mem, COMSORT equals %CPU let you isolate exactly what matters. Common mistakes: confusing PSO, BSD syntax, with PSF, systemv syntax, and mixing their flags, forgetting that grep itself appears in its own output, and ignoring zombie/defunct processes that signal a bug. A mini example: PSEO PID, PID, user, stat, com, grep-z reveals every zombie on the system, its PID, and its parent responsible for reaping it. In a security context, spotting an unexpected process running as root, or a hidden process consuming resources, is often the first sign of compromise. Workshop brief. Your goal in this workshop is to build fluency in listing, filtering, and interpreting the process table on a Linux machine, then to apply that skill to a basic security triage. You will produce a short written report, Markdown or PDF, documenting your commands, their outputs, and your analysis. Work on a Linux VM or container you control. Ubuntu, Debian, or Kali all work. Do not run destructive commands on a production or shared machine. Step 1. Take a full snapshot of the running processes using both PSO and PSF. Identify PID1, note its name, and explain the difference between the two output formats in your own words. Then locate the three processes consuming the most CPU and the three consuming the most memory, using a sorted PSEO expression. Record the exact command you used. Step 2. Master filtering. Find every process owned by root, every process whose name contains a service you choose, SSH, bash, systemd, etc., and count how many processes each user on the system is currently running. Use grep, pgbrep, pdoff, and pipes. Demonstrate at least one case where filtering with PSEO, grep and filtering with prep give equivalent results, and explain why one might be preferable. Step 3. Explore live monitoring. Launch top, and head top if available. Then in your report explain how to sort by memory, how to filter by user, and how to identify the process state column. Deliberately create a background process, for example a sleep 600 or a small loop, find it via filtering, note its PID and PPID, then reflect on how a defender would distinguish a legitimate background job from a suspicious one. Step 4. Security triage. Search the process table for anomalies, unexpected owners, unusual command names, processes with no controlling terminal, or defunct/zombie states. Even on a clean VM, describe the exact commands you would run to hunt for a hidden or malicious process, and justify why each command matters in an incident response scenario. Conclude your report with a short paragraph linking process inspection to the broader work of a DevSecOps specialist. Why does knowing what runs on a host matter before pen testing or securing an application? Submit a single document containing, for each step, the commands executed, a representative excerpt of the output, and your written analysis. Clarity and correct interpretation weigh as much as command syntax.